Right, good morning, everybody. My name is Paul. This is a webinar focusing on BIM 360 design and coordinate, where we are going to have a cursory look at worksets and phasing used in Revit projects and how that is used on BIM 360. It came about, the idea for the webinar came about from one of our clients asking us how to manage their phasing and work sets within BIM 360, and I'd like to focus on that. In preparation for the course, I've designed a small model. It's very small. It's easy to work with and demonstrate, and hopefully also very simple to illustrate on Revit 2020. And then I also have a more advanced model on Revit 2021, which I'd just like to refer to very shortly. So let's have a look at what we are going to see during this webinar. It's the BIM 360 Design and Coordinate platform. And we're looking at managing worksets and phases. In the agenda, we're going to have a quick intro. We're going to have a look at children files and parent files. You might also understand this as a container file and n-tier links that will come into the container. Worksets, that is what we use when we have the full Revit and we are working in team on a model. And we also use worksets when we link other models into our model. Phasing, typically that would be applicable where you have an existing building and then you either modify that building, or if you have a large project, then you might have phase 1 and a phase 2 during the construction, or any time-based sequencing of construction activities. We're going to have a look at setting up views and also publishing on BIM 360. That's something that's unique to the BIM 360 platform, and then also on the management of views. So the phases and the worksets have implications on how clash detection is performed in BIM 360 Coordinate. This is a new generation platform. The rest of us might be familiar historically with Navisworks and with Glue and BIM 360 Field, but the modern way in which Autodesk is going is to do clash detection much faster in BIM 360 Coordinate. It's a license that you can buy on BIM 360 and that will allow you to do clash detection. The setting up of a BIM execution plan is critical to ensuring consistency in naming and applications across the supply chain. So if you're not familiar with a BIM execution plan, it's a document that is rolled out across the industry or across the supply chain, the different stakeholders in the supply chain, the different disciplines. And everybody then conforms to the standard that is required by the principal agent or the company that is responsible for managing that project. If the models are correctly set up, then you must be very careful to make sure that the models are correctly generated and clashed. Worksets can be slaved or independent without a change in the result, although slaved worksets may turn out to be easiest to manage. This depends on consistent managing of worksets. So it sounds like a mouthful, but it's actually quite easy to understand, and we'll illustrate that shortly. So if this is Greek to somebody here, don't be concerned about that now. You'll see it in action shortly. And then if this is old news to you, then please bear with us and we'll have a look at that. So first of all, what is a child file? A child model in this instance refers to an n-tiered model that is linked into a container for clash detection purposes. So let's suppose that in a very simple environment, we've got one architectural file and one structural file and one mechanical file. Those are then the child files, and they will be linked into a container file from which we can generate our views. Right. So BIM 360 design is used for collaboration. Then packages that are shared with other teams are immediately available in the shared section of BIM 360. Now, let me just show you what that looks like. So what you can see on the platform at the moment are two tabs. The one, as you'll see in the naming of the project at the top there, is BIM is a 2020 project. And then the modern day, or the newest version of the software, is 2021. In 2020, we are able to do the coordination within plans folder. For this specific webinar, I'm looking towards the test folder. But in 2021, they've changed the API, and so we actually do our coordination within the project files folder. So just note, if you go from 2020 to 2021, that the location of the coordination folder is changing from the plans folder into the project files folder. The reason for that is that Revit itself does not allow you to save a file directly into the plans folder anymore. Okay, so there's a change from 2020 to 2021. Now, in BIM 360 Coordinate, if you're familiar with it, look at this one here. The design collaboration, in other words, the BIM 360 design license, how it is organized is that we work in silos. You might be familiar with this. If it is new to you, this is a way in which the different disciplines share their files with each other. So there's a timeline with the different disciplines, and at specific instances they share packages with each other. And once the package has been shared, somebody else will consume that package. So, to put it in simpler terms, the BIM manager from the architect, AX1, shares their package, and then after that, the BIM manager from the mechanical company accepts that package. So it's not a unilateral decision. The model is checked twice, first by the authoring party and then by the consuming party. The result of that is that we end up with this collaboration folder on BIM 360. Each team has their work in progress models, which you can see here. On the mechanical side, there is their model. But inside of each one of these teams, they call them teams, is a consumed folder. So these are the packages from the other disciplines that were consumed by the architectural BIM manager. So that is the mechanical file which is suitable for linking into the architectural project. Now that is a traditional workflow. Now there are various options in which you can set up the coordination file. One of them is to create a team that will sit over here which is dealing with coordination, and then to link into the container or the parent file the children. So if the architectural discipline was in fact a coordination discipline, then the consumed folders will contain the children files. And that wouldn't be a unilateral decision. The alternative to that is to work in an at-risk environment, which is what I've done in this case. And this is the shared folder. So as soon as you create teams that you find here, and somebody shares a package, they become visible in the shared folder. So that is a unilateral decision. If the architect shares a package, it immediately shows up in the shared folder. So if you have access to the shared folder, you can, or not consume, you can use unilateral shared files from the different disciplines. So it's immediately available. The advantage to something like this would be if there's a good trust between different companies, then if I am the architect and I share my package and I don't want to wait, then I can immediately see the results in clash detection of me sharing my model with somebody else. So it's an immediate feedback to the publishing party. It's an immediate feedback to the person that has shared the package. Okay, so it's a nuance, but it is at risk. And the alternative to that would be to rather let time elapse and then to work in a non-unilateral manner where all the managers check each other's work as well. And in that case, we would have to create our own team. And that's all based around the design license. And then we've got the coordination folder. And what you'll see in the coordination folder, if I open this, is a single file. And this file links the shared files into it. Okay, so the architectural file in the shared folder, the at-risk folder, that is shared into my coordination file. So this is the parent file. In this 2021 case, this is the parent file. And this is the child file. If we didn't do this at risk, then we would have our coordination team and the parent file would be in here and the children would be in there. All right. In 2020, I've created this test folder that is going to indicate that we've got the somebody there. Right. So because it's in the plans folder over here, you'll see a lot of files. And because this is in the project folder, you won't see so many files. You'll only see one file. That's the cause of that is that the plans folder extracts views into the folder in which you load the file. So let's have a look at where we are with the webinar. All right, so we've got our child files and only published views are available in the package files. Right? BIM managers have access to the shared folder and then do a live clash detection. Clearly, this must be managed by protocols and no unwanted changes are affected. So in other words, it's at risk in my case, but you could also make that so that it isn't. The alternative is to upload the new package file from a consumed folder, but this would give not immediate feedback to the manager. So we've just discussed that. Then let's have a look at some of our Revit files. Within Revit, when you've got the design license, you have access to these models on the cloud. What's nice about this license is you can be anywhere in the world, and as long as you've got internet access, you can access your models. And looking at the in the project files, in our let's quickly see where this is linked in everything. So here we've got the image links. We're loading this one in from the project files test folder. In project files, this is test folder. There it is. So here we've got two files. One is an architectural file, and the other one is a structural file. So I've made this as simple as possible to get the concept across. And we're going to look at how we structure both phasing and worksets. And it's incredibly simple. It's just a few walls. So how this came about was the architect. In this case, what happened was the architect had some walls, which you can see here. And these walls have foundations attached to them. And the way that they manage their project not necessarily the way that I would manage a project, but the way that they managed their project was they then switched off the architectural work set and supplanted the walls with the structural walls that you see here. So they used the foundations from the architect and ultimately superimposed that with the walls from the structural engineer. They also used two phases. So looking at this structural wall, you see that the phase is new construction, and in this one, the phase is existing. Just very simple. You'll be used to the terminology as well. Nothing complex. The two phases, these walls exist in the new construction phase. Those walls exist in the existing phase. Similarly, in the architectural files, these walls are new construction. Those walls are existing. And it's the same for the foundations. Right, so there's two phases, very simple. Then we create work sets. We must be careful how we name the work sets. I used A for architect _ foundation for the foundations and A _ wall for the architectural walls. We can look at those by work set, and there we can see them very clearly. Then in the structural file, we also have S for structural _ foundation and S for _ wall for the structural walls. Now we have no structural foundations, but we create it anyway. Maybe we draw a foundation in the structural foundation sometime in the future, but there they are. Just for comparison, S for structural, and there we can see if we look at that per work set, there it is on one work set. Right, so there are the two files then. A and S. Now, the file that you see here is the container file, the parent file. Just to show you on BIM 360 what that means. The two files that we are working on are in the project folder there, it's test. This could just as well be the shared folder in 2021. There's our architectural file with the A _ wall and A _ foundation workset. And there is the structural file with the S _ foundation and S _ wall workset. Both of them have the same phasing, named exactly the same way, existing and new construction. The file that we are saving as the container file is sitting within the test folder. Okay. So when we link files in, we typically give the file name. This would normally be a long name according to the BIM protocol, but I've shortened it just to make it simple. Arch refers to the architectural file that we bring in, and when we link that file in, we put it on its own workset. That's typical workflow. And the same thing with the structural file. That's a typical workflow. Then we also create worksets that are exactly the same name as the worksets in the children. A for the architectural file, A _ foundation for the foundations, A _ wall for the walls, S _ foundation for the structural file, and S _ walls for the structural file. So we've got one workset for the file itself, and then the work sets that occur within that file. So immediately you can already sense we'd like to differentiate between the disciplines in their work sets so that we can generate work sets for that file, that we can manipulate the elements within that file. It might not be evident at this moment in time. I'll show you later on a more complex file how this can be quite a complex situation where for each floor you can create its own work set. Ultimately, we'd like to clash detect on a level, and we'll see how that works. But like I said, this webinar is about how you manage your work sets and your phasing. Right, so this is the container file, and we've brought those two files in, the arch file and the structural file. Now, when we load this file, or publish, the correct terminology is publish. When we publish this file into the cloud, the 3D views that you see here, this is a 3D view or 3D arch independent. That's 3D arch slaved. So these are the architectural views, three-dimensional views, and these are the three-dimensional views for the structural worksheet, or the structural file. The one is independent and the other one is slaved. One is independent and the other one is slaved for architecture. And the reason I'm putting them there is because I'd like to illustrate to you that it is not necessary, it doesn't make a difference if you have them independent or slaved, but that slaved is easier. If you want to use the slave method, then you should have the work sets reproduced within the parent, just like we've done here. If you went independent, you would not have to do this. You could just have the arch and the structural file linked in, but then it's going to be some more work for you. When we start a new view like this, we create a new family for that view. You can see when we edit the type, there's some different view families that were created, independent and slaved and independent and slaved, both for architectural and for structural. So that's why you see these families of views over there. In addition to that, we've also created a view template for each one of those families. And note carefully that the phase filter has been left open. Okay. So in each one of those view sets, the phase filter has been, the civil engineering one is not of interest here, but in each one of these four that we created, we've left the phase filter here. So when we look at all from an independent link workset, we are seeing all the phases. Okay? And that's because the phase filter is set to none. So it's showing the existing phase and we're not putting on a phase filter. Let's have a look at how we manage the worksets. Clearly, we would not like to see in the visibility graphics override the worksets. Let's have a look at how that is set up. Right, so it's all visible here, and there's the Revit links. Both of them are on. And because we're independent, we are not managing them through the worksets, we are managing them through the individual link. We have to dive into the architectural link and there are the worksets that we can change. In this case, everything is on, so we don't need to change anything. All the worksets are on. Existing. There are the Revit links. In the structural file, set to custom. See how the structural worksets are off. So that's true for all three of these. They've all got the same view template where the worksets are all on. Then the Revit links in the structural worksets are switched off. Okay. So what that is saying is we've switched the worksets off in the link. In other words, it's independent. We manipulated the link itself. Compare that to where we have the slaved situation. It looks the same geometry is visible. Let's have a look at the view template now. Specifically at the worksets, you see how we are now manipulating the link through the worksets that's native to the parent. These are the parent worksets. And I'm saying hide structural from within the parent. That then translates into the structural file by host view. I'm not overriding anything as custom, but you can see in my worksets how the structural worksets have been switched off. So these worksets are being slaved to the parent worksets. The reason we can do that is because we created worksets with exactly the same name in the parent. So that is what's meant between managing independent or slaved worksets. So that is something for you to consider in the future. How would you like to set your models up when you link them in? Similarly, under the structural, this workset over here, we would like to see everything. There is the existing, and there is the independent. That looks the same as this one over there. Okay. So what we've done here is we just actually left the architectural foundations on. That's actually a mistake on my part. I do apologize for that. Let's have a look at this quickly. There's the independent workset. There's the view template. Because it's independent, I'm expecting nothing to be changed on the worksets of the parent file. Everything is on. Mfindo, thank you very much for attending. Like I said, we do apologize. Sorry, Mfindo just has to leave us at the moment. Thank you very much for attending. It was a pleasure having you. We will certainly share the link with you after the recording. Apologies again for starting late. There was an issue with the TeamViewer link. And thank you very much. And I hope you have a great day further. All right, sorry for interrupting the webinar there. Just in case anybody else has to leave as well, just again, our apologies for starting late because of the TeamViewer issue. Right. So these are the parent worksets, and in the Revit link, we'll see there's the custom override on the architectural worksets now. We set that to custom, and there are the worksets. I'm switching off the wall. If you want to switch off the foundation as well, it's easy. We switch off the foundation. And then the foundation disappears. Remember, the foundation was attached to the architectural wall, not to the structural wall. The same view template is applied to all of these, and then we've got this one over here, which is the slaved worksets. And in this case, we're going to see that the parent worksets are slaving, so we're hiding the architectural wall. We want to hide the foundation as well. We then hide the A foundation in the parent that propagates through into the link. Even though we're not overriding anything, the work sets are slaved. Okay, so the all that you see there refers to the fact that we are viewing this view by phase existing, phase filter none, existing but show new, and new construction and show new. So all of the news we'll expect the same. New construction, show new. New construction, show new. New construction, show new. They're all the same. Existing and show new. Existing and show complete in this case, sorry. Existing, show new. Existing, show new. So this one, we actually change that to be the same as the others. Okay. And then the same thing as well for all. They're all the same. Right. So phasing, all. Phasing, existing, and phasing new. So however many phases you will have, you could set up 3, 4, 5 phases, you'll have 3 or 4 or 5 of these there. The reason we do it like this is so that we can clash the different phases with other models. The fact that we've got independent and slaved simply shows you that you can manipulate the work sets either from within the links as independents or from within the parent as slaved. So once we've now brought our models in, this is just architectural and structural, you could also have mechanical, ICT, electrical, interior design, whatever disciplines there are, you will then have families within the container model where you can set these views up. Next, you have to decide what you're going to publish. And to do this, we go to the Collaborate tab and we have a look at the Publish settings. Here you can see all the views that I've decided to publish. Now these views are the ones that will be extracted for me to clash detect with. So let's suppose I had a Navisworks view where everything was switched on and I didn't want to see that within the clash detection. I simply would not tick it to share it. I would just say these are the views that I want to use clash detection from. So the publishing settings is important in that sense. And the step after that is you will then manage the cloud models and then you can publish your containers. So if we look at this project over here, it does take a little bit of time to publish. But those views are then extracted as 3-dimensional models or 3D models with which we can clash detect. So we've done some other webinars as well. If you are interested in clash detection, we focus specifically on clash detection. Post that webinar, this question came along. Great, you've done clash detection. Now, what about phasing and worksets? Well, it works the same. Okay, so we're not going to do so much clash detection during this webinar. I'll refer you to one of our other webinars for that. But you can definitely see it. You can manage your worksets. Let's have a look at something else. Let's have a look at what another file might look like. Okay, so this is now my 2021 project. I'll be waiting for, there we go. Right. So there's our container file, and we've got a new version that we can publish, and then we publish. Okay. That now publishes up into this area over here, into the test folder. So here we can see Everything here is July 20th, so we'll expect them to be updated shortly. Right, while we're waiting for that, let's have another look at our notes and see if we understand what we've learned, because it is overwhelming when you just read something like this. So a child model, in this instance, refers to an entity model that's linked into a container for clash detection purposes. In other words, the different disciplines are linked into a container. BIM 360 design is used for collaboration, and the packages that are shared with each other teams are immediately available in the shared section. Saw that about the at risk or not at risk. And published views are available in the package files. And that's what we've just done. We've just published those 3D views that we've created up into the cloud. Web managers that have access to the shared folder may then do a live clash detection. Clearly, this must be managed by protocols and what changes are affected. And then the alternative is to upload the new package files from consumed folder to not give feedback to the managers. Right. Parent file, which is the one that we've just created. The parent file refers to a container that is used to prepare views for clash detection. We've just seen that. Because we can manipulate the worksets within the files, isolate elements with which we want to clash detect. Phases and worksets can be used as to organize disciplines by level and phase to prepare extracted 3D models for clash detection. That's what we've done. On a large model, so we didn't do this by level because we didn't look at a complex building, but typically you would do this by level as well. Right. On a large model, this takes a lot of setting up, after which the clash detection is automatic. So the guy that sets this up, the BIM manager in charge, or whoever is responsible for the clash detection, they would set it up once, and afterwards it should be automatic as the files are shared. And then we've got models that are models must be carefully prepared and audited before sharing to make sure that they conform to clash detection requirements. Right? So there must obviously be a protocol which must govern how everybody prepares their models, and this process must be automatic using the BIM interoperability tools and or Dynamo. So there are tools within Revit. If you're not familiar with them, this is now published. Within your BIM interoperability tools, it's a great add-in that's also done by Autodesk. You'll find that you can run some clashes, not clashes, but you can run some tests on your model using your model checker configuration over here. And then in addition to that, you can also use the Dynamo add-in to automate. Okay. So there are ways and means in which you can try and speed up the process. Worksets, slaved versus independent. If the same worksets are created in the parent that exists in the children, and the child worksets can be slaved through visibility graphics overrides. This makes the management of the views easy. It's not necessary to delve into the link to custom override worksets. If you don't have to manage something repeatedly by diving into the links, you can manage it from the parent. That's much easier. And alternatively, the worksets may be custom overridden. That's when you have to open the link and to manipulate the worksets inside the link. The elements in the view can be shown per phase. We've seen that with the phase filters. Create the views to show the required phase. We've done that. And then we publish the view to make it available to clash detect. You need to name the views consistently and pedantically, usually by rolling it out in a BIM execution plan, which will tell all the different companies and the different disciplines exactly how they must name their worksets so that we can manipulate that from the parent. Use view templates. You saw that as it applies across all the filters, so it's easy to manage in one place. And then remember to add the views as the project progresses. If you add new levels, create new views. Or if you add new phases, then you have to add to that process to clash detect correctly. Okay. Publish the required views and set up the clash detection views in BIM 360 coordinate. All right, so here is an example of something I prepared for an earlier webinar. It deals with a much more complex situation where it is actually quite a large building. And in this building, we've got different levels. So if we look at the architectural, there's the basement 3 elements. There's basement 2 elements, which there are none. Basement ground floor, I know there are some. And then mezzanine 1, mezzanine 2, and so forth. All right, so each level has its own work set. Right. So here you can see that the work sets have not been created in the parent. So I can't do these as slaved. But looking at the visibility graphics overrides for this view, going into the Revit links, you can see how the work sets are available for each level. So if we did this in the way that we did with the smaller file, then for the structural and the architectural and the mechanical, possibly not the mechanical, but definitely the structural and the architectural, we could isolate per level the geometric elements so that we can clash that, say, with the piping in the mechanical level. So we can pick up on level mezzanine 2 which mezzanine elements are clashing with piping or with electrical. So it's per level. And then one can extract that. On the structural side, it's the same. So each level is isolated through work sets. You can also do this by putting a section box around the elements. But that is more difficult because, just see if we can switch this on quickly. Not sure where the section box is at this moment in time, but there's usually a little box that comes around the elements when you do a section box around an element. But you can't align that section box to references. You can't say only perfectly give me everything on level mezzanine 2. You can say kind of there and thereabouts, plus or minus a few centimeters this way or that. And that's not super accurate. So if you want to do this accurately, then you can put your elements into work sets, one for each level. And then when you publish, you can then publish all of those views, one for each level. And those are the views that will then be extracted to clash detect with. So here you can see how in the test folder in 2020, remember it's in the plans folder. In 2021 it's changed. You don't have it in the plans folder anymore. In the test folder, there you can see that the version 3s that were extracted, we've got one for each view that was created. Also with the container, it automatically creates a container existing and a container new, one for each phase. So that confuses people at times, but just note that the 3D models for each phase of the model, a 3D model is created, and then in addition to that, so these are the ones that you're not publishing. This model, and that model are not views that I chose to publish. They represent the parent. But the other views that you see here, those are the ones that we published. So don't let this confuse you. It's not something that you've got control over. Every phase will be represented by a separate 3D model. And then the other models that are extracted, those represent your views. And ultimately what that results in, if we have a look at our coordination folder, this is now in 2021, even though I've published views here, they're not visible. So compare what you see in 2021 to what you see in 2020, and then you'll notice that here's lots of files, there's only one file. That's going to be the big difference between 2021 and 2020. So there's going to be lots of files, only one file. When we then go into the actual coordination, That's one of the licenses that you can buy. Then the extracted models are shown. Just wait for it to update. There are the extracted models then shown. Right? If you look at a matrix which compares them, you'll then see how each one of those extracted models compare against the other views. There you can see lots of clashes, so clearly something's very wrong over here. But in any case, this, like I said, the actual clash detection that we deal with in another webinar, but how you set it up, that is what we looked at in this webinar. How do you set up the views so that they get extracted? Right. So these views that you see here correspond in 2021 to the views that you see in the plans folder. In 2021, they've changed it across so that we only see one file. There we can see only one file, the coordination folder that we are working in. Right. So even though you see only one file, notice that when you open your coordination module, the extracted views will be available for you to see. So let's look at something like, let's take, I'm opening one of these, let's just take one at random. These are old published views as well. We can then see that it's going to do an automatic clash detection. This is quite a, it's not the file that I'm wanting. AX, this is GX, then AX, this is AX. Let's try this one. Okay. So here you can see there's a larger structural model, and then we've got this other model in there as well, and it will automatically pick up the clash detection. Right, so if you focus on one of these, there you can see where it's clashing, or that one. And you can also create issues about this clash detection within the model. Like I said, I focus very in detail on the clash detections in another webinar, and I'll also share the link with you so that you can see how that is handled. But this webinar is about how we set up our Revit models. Very simplistically, we started out with a view, phases, and worksets, and we shared those child files into our parent, and then we generated our 3D views based on the phasing and the worksets. After that, we decided which views to publish, and then we updated the cloud model so that those views can be extracted for clash detection. So that concludes the webinar from a presentation point of view. I don't know if any of you have any questions at the moment. Maybe I can ask a question. Have any of you done this? Have any of you worked with BIM 360 Coordinate before? Have you used the design license? Are you familiar with the cloud? Or is this all new to you? Not yet, right, not yet. Okay, fantastic. All new. Okay, okay, that's also good news. Okay, so you've seen something new today. It is fantastic technology. D2 Design Lab also, not yet. All right. So I would definitely think about this. If you can get involved in BIM 360, it is the common data environment that Autodesk is busy creating. It's a work in progress. If you want to learn more about the platform, I refer you to the following link. I think, Brian, you'll find this very interesting as well from a construction point of view. It's called the Autodesk Construction Cloud. So Autodesk is investing very heavily into the technology, and they are also buying other packages and integrating that within the Autodesk stable. I see that just bought Pipe as well. And there you can see all of the products that are available. So today we had a look at design collaboration, just cursorily, in the sense that we created the files using design collaboration on the cloud, working in teams. We didn't see how to share packages today, but you share packages and then you consume the other disciplines' packages. So that's what design collaboration is all about. You can collaborate with anybody in the world, a fantastic resource. We've got the coordination license, which is the clash detection license. Okay, so we've only looked really at that design authoring, design collaboration, and BIM coordination. That's as far as we've gone. But in addition to that, we've got all of these other licenses for quantification, estimating, bid management, qualification, project management, cost controls, field collaboration, quality and safety, commissioning, and then asset lifecycle, facilities maintenance. Now this encompasses the entire life cycle of a built asset. And then in addition to that, we've also got these new platforms that has been integrated with the construction cloud as well. So over and above what Autodesk has done in the past, they've also assimilated Assemble, Building Connected, and Plan Grid, and now also Pipe. So the Autodesk Construction Cloud, this is a wonderful resource for you. If you are interested to see where the construction technology is going worldwide, there is a fantastic resource for you to just learn about what is out there. And then at Micrographics, we'll continue to do these webinars. In my next webinars, I'll be specifically focusing, just if you're interested, I'll be specifically focusing on the BIM interoperability tools. The first webinar is going to be about how we are going to assign coding to our elements. And then the next webinar is going to be about how do we go about using COBie. So COBie is a typical standard that is required overseas in America, in England, and also in the Middle East. So these tools make our life a lot easier, and that's what I'll be focusing on next. But for now, I thank you very much. Unless there's any further questions, we can conclude the session. Once again, our apologies for starting late because of that TeamViewer link. Hopefully we won't have that issue again. And best of luck to you all out there. If you have any questions, please contact us. You've got our email. I trust you can get hold of me personally. I'll put my email into the message box there. And then you are most welcome to join us for the next webinars that we are going to have. Right, guys, best of luck out there. Have a great week further, and I hope you've all got great success with the technology that we've got. Thank you, Brian. Thank you, T2, Design Lab. Sorry, I don't have the name behind the name there, but have a great day further. Cheers.